Hi folks, so the questions we're actually faced with here today, guys, are based off the topic of solids in contact. It's from the DCG Solutions textbook and it is page 60, solids in contact, sheet 3, okay? So previous to the last videos that I've done on solids in contact, this is just a follow on from those, whereby we're given solids with points of contact and we have to find a sphere or a cone that touches other solids at those points of contact. Okay, so what we're going to do is we're going to start with question 1 and we're going to work our way through all 4 questions until we get to the end. Okay, so I'm just going to flash there to question 1 now, guys, so I'm just going to do that. Okay, so we can see here, guys, on question 1 it says, shown are the plan and elevation of a cylinder. The given point is on the surface of the cylinder. Complete the projections of a sphere which rests on the horizontal plane and touches the cylinder at this point. Okay, so basically what they're asking us here is, we have a cylinder here in front of us and it tells us the point of contact where we want a sphere to touch the cylinder. Okay, the other bit of information tells us is that the sphere is resting on the horizontal plane. So what that means basically is that the sphere is sitting on the XY line. It's resting on the horizontal plane, which basically means that the sphere is sitting on the ground, okay, on the horizontal plane. Okay, now the other thing that we note is that the point of contact is a certain height up from the XY line. Okay, and I'm just going to bring you here a little bit of attention to, okay, this is literally just bottle of aftershave, okay, or just deodorant, and it's in the form of a cylinder. Okay, obviously now that's what you would see when you look down top of it, but for the sake of it here, when we look at it in the elevation view, okay, so what you have in the elevation view there is a cylinder, okay, which we see as a rectangle. Okay, I'll just zoom out there so a little bit better so you can see it. And what we're also going to have is we have a sphere. Okay, and technically that sphere at this moment in time, the position they want us in is about there, where it's resting on the horizontal plane. Okay, so if you imagine there's a ground here and they're both sitting on the horizontal plane. Okay, and the point of contact is in there somewhere. Okay, so if I was to move it up, it would look probably something like that, and we can see where the point of contact is down here. Okay, but essentially that's what we have at this moment in time. Now that point of contact, it's in there. The only way we can see where the actual point of contact is, and like we did in the previous day, is when we rotate the sphere to the side, okay, and we can locate where the exact point of contact is. Okay, and that sphere then, its radius will be up whatever height that point of contact is from the ground. Okay, that's the idea of how it works. So if you imagine there, okay, the sphere is resting on the ground. Okay, I'll try and bring it up into a view that you can kind of see it better, and we can locate exactly, if I bring it in, we can see where it's touching there. Okay, and when it's touching there, we can tell exactly from the ground how high up it's touching. So the point of contact up, okay, if I was to go back here, that point up from the XY line is actually my radius from my sphere. Okay, because we know the radius of a sphere that's touching a cylinder has to be along the diameter. Okay, basically. Alright, so we're going to use that to help us basically complete this problem here. So I'm just going to zoom back in there now. And what I'm actually going to do first of all is I'm going to locate that point of contact, okay, at the side on the extreme generator of my cylinder. Okay, remember that is the extreme generator of my cylinder, this is it on this side. So if I was to do a horizontal cut going across from left to right, okay, all I've actually done there really is I have rotated the point of contact around the cylinder. Okay, that point of contact technically in my plan, I'll locate it in my plan. I'm going to assume that it's at the front. That point of contact in plan is actually down here. Okay, all I have done is basically I have rotated about the center of the cylinder. Okay, I have rotated that point of contact until it's in this position here now. So I've basically moved him where in this position here, whereas in my elevation view that appears like it's moving on a straight line. Okay, whereas in reality we know it's kind of moving on a curved surface. Okay, so next step is getting that ghost cylinder, okay, and it's all about finding the center of it. Okay, so I'm just going to extend out this line here, okay, and using my compass I am going to take the radius, okay, as I said previously, remember, okay, it is the diameter, okay, the center here down to the XY line, the point of contact is going to be the radius of my sphere. Alright, so what I'm going to do is I'm going to take that distance from the point of contact down to the XY line, that's going to be the radius of a sphere that is touching the cylinder. And from the side of my cylinder, the extreme generator, I'm going to mark that out. Okay, and there is the center of a ghost sphere, okay, that touches on the outside. Now I'm going to put in the ghost sphere on this question here, but as time goes on, we only need the center. So there we go. That is what's called my ghost sphere or ghost circle. Okay, ghost sphere. And obviously a sphere, in any view you'd see it as a circle. Okay, at this point now I have found that ghost sphere. I'm now going to project it down to its position when it's at the side of my cylinder. Okay, I have extended out the axis of the cylinder there. Okay, and now I've found the position of the ghost sphere when it's in this position here. Okay, this time I'm not going to actually draw in that ghost sphere because it's not what I actually really need. But what I am going to do is I'm going to rotate the ghost sphere center, okay, about my cylinder. Okay, so using the center point of the cylinder, I'm going to rotate that around, and literally I'm going to rotate it, okay, around there. And we know that a cylinder and a sphere, okay, their points of contact in plan view will be located by joining the two centers. So if I join the center of my cylinder through the point of contact and extend it out, I have now found where the center is of my actual sphere that I need in plan view. So I'm going to put that in heavy now. So I'm just going to use a different color pen there. I'm going to use a black pen. And what I need to do then is take the radius again from here to the point of contact. Okay, and as best I can, that is the position of my sphere in plan view. Okay, right there. And now that I have that in plan view, I can now project up my center to the correct position in elevation. Okay, I have now found the correct position of it in elevation. The center is right there. And taking the same radius, I am now going to draw in that sphere in elevation. And there we go. That is the sphere in elevation, okay? A little bit of inaccuracy there, just went under the line, okay? You could work that out yourself. But that there now, and I would always actually, just to go back over myself there a little bit, locate POC. Don't have to circle them obviously on the day of an exam, you just mark it POC, okay, but I'm just pointing it out for the sake of the video, okay. And there you go, we have now found the sphere in elevation and we have found the sphere in plan. And in my elevation view also I should have, because the sphere is in front, just to put this in here, technically the lines are kind of all heavied in already, but that should be hidden detail. Okay, so I'll just go back over them. Hopefully that comes up okay on the visualizer, guys. Alright, and there we go. That is the elevation and plan view completed. It said complete the projections of a sphere which rests on the horizontal plane, touches the cylinder at this point. Okay, that's the first question there, guys. And it all came from basically the point of contact, which gave us a lot of the information, okay, and our understanding of how we can use that point of contact to help us. Okay, so at this point now, guys, I'm going to move on to question 2, so I'm just going to zoom out to that one there now. Okay, guys, so the next question here is question 2 on the page, and it says, shown are the projections of a cone. The given point of contact is on the surface of the cone. Complete the projections of a sphere which touches the cone at this point of contact, okay, and rests on the horizontal plane. So once again, kind of similar enough to the last question where we have another sphere, only this time instead of touching a cylinder, it's touching a cone and resting on the horizontal plane. And we can see the point of contact down here where we want it. So I'd imagine we're going to have a sphere somewhere in a position like this here, okay? But anytime we're doing one of these solids in contact questions, what we're always going to do is we're going to get the sphere or whatever object it is, or a cone or a hemisphere or a pyramid sometimes, we're always going to get them first of all when they're touching the extreme generator on that point of contact. Now our first step with this one is actually locating our point of contact in our elevation view, okay, and also locating it where we're going to use it out here on the extreme generator, okay. But the first thing I will also do is I'm going to just label, okay, always with my cone I like to label it. I'm going to label the apex there O, this point here A, and this point here I'm going to label it B on the inside, okay? And that means if I follow A up, A is there, O is up here, and B is down here, okay? And basically when we're looking at the front view or the front elevation of the cone, we obviously see a triangle, but that triangle that we see is actually a line here in plan, and it's actually our axis running across the cone, AOB, AOB, because when we look in straight at it, okay, we do see this curved face, but really what we're actually seeing is a line from A to O and O down to B. That's actually what we're seeing, okay? Even though it's actually not an edge, it's a curve, we know this, but that's how we see the cone, okay? So now the next point is, as I said, I want to locate that there in elevation. So this is going back to just locating points, okay? So what I'm going to do is I'm going to use the generator method. It's the one I find the quickest, and I'm going to take a generator from my apex through my point of contact, okay? And I have now found a point here which is on the base, because that circumference is on the ground, okay? And I'm going to project that where it hits the base up to my elevation. It's going to hit here, and like I did down here, connected it to the apex, I'm going to also connect it to the apex of my elevation. Okay, and now along that generator I can actually find the point of contact in my elevation. So I can see that that point of contact in my elevation, sorry, use a different colour there, is, now sometimes there's a little debate, is it here, is it here? Try and go roughly where you think it is, right in the centre of it there. So that's my point of contact. Once again I'm going to write POC, and I'll write it up here as well, POC. Okay, now we know with that point of contact, okay, there's two ways we could do it. We want to bring it to the outside, to the extreme generator, okay? So working backwards here now, alright, we are going to transfer it across, and I'm going to take a horizontal cut. Okay, now usually when you do a horizontal cut it'll be going all the way across, but just to show you there, I only need to transfer it around as far as here. Okay, so I'm just going to transfer that across, and now technically my point of contact for a sphere that's touching the cone and the ground is on the outside of it, okay? And what I've done is I've just rotated around. And in plan view, what that actually would look like is, even though it's a straight line in our elevation, or a horizontal line in our elevation parallel to the XY line, it's a horizontal cut. That cut would appear like this in my plan view. Basically all I have done in elevation is, and as it would look like in my plan view, is I have rotated it around. Okay, and technically that point there matches up with this point here. Okay, but obviously we don't need to do that, it was just a case of proving it. Alright, now the next stage is we have to find a sphere that's going to fit inside here. Okay, the method we did the last day when we did one of these similar questions was a sphere will touch both the extreme generator, the line OB, and the XY line, okay, anywhere along a bisected angle here. So our bisecting angle is OBY. Okay, so I'm going to bisect that angle. Okay. Having bisected that angle now, okay, having bisected that angle, somewhere out along that bisector line of that angle, okay, is the centre of a sphere that touches both the extreme generator and the XY line, which is actually our ground line. Okay. Once again, we're going to use the point of contact to actually help us determine the exact center point. It doesn't tell us the radius, okay, of a sphere, okay, so we don't know how high up it is just yet from the XY line, but what we do have is the point of contact, okay, and what we did was we rotated that point of contact around until it's on the extreme generator. Another principle we learned was perpendicular to the extreme generator, okay, from the point of contact, so perpendicular to the extreme generator through the point of contact, okay, will help us locate our center. Whereas the last day what we had to do was find the point of contact, and what we did was we went perpendicular to the extreme generator from the center of our sphere to locate the point of contact. So we're just working backwards. we're going perpendicular from our extreme generator from the point of contact to locate our center. Okay, so just a little bit of sliding set squares here now, guys. So just want to rotate my set squares I need to. Hopefully my visualizer doesn't get in the way. So lining up my 45, and then hopefully it's just got a little bit in the way there, guys, so apologies for that. Now I'll line it up this way, and what I'm going to do is just slide this one a little bit to the left, and then I can go perpendicular that way. Okay, so from my fake point of contact, okay, that angle inside in there is perpendicular, and where that angle has, or the perpendicular line has gone through the bisected angle, I have now found the center, okay, of a sphere that will touch both the XY line and the extreme generator. I'll put it in just to prove it to you, okay, and depending on my accuracy, hopefully it'll work out, and that is not too bad. Okay, we can see the sphere actually is quite a big one. Okay, once again, that is a ghost sphere. Okay, a ghost sphere. Okay, didn't have to draw it in. The whole purpose of that exercise there was actually finding the center of it. Now that is the sphere when it is touching the line OB here in plan. So what I want to do is I want to transfer that center down. Okay, so transfer that down to my plan. Going to extend out the axis line. Okay, that's where it would be in plan if I was to draw it in. I'm not going to draw it in, but what I am going to do now is I'm going to rotate it around my cone. So using O as my center to rotate it around. I've rotated around into the position there, and we know what we have to do to find the points of contact in plan is we have to join centers to each other. So if the sphere was here already, I would join the center of the sphere to O, and I would locate my point of contact in there. We're just going to use the point of contact to guide us. Okay, so literally just extend out from O through my point of contact, and there we go. And what I have now found is the center in its correct position right there. Okay, so once again, just want to switch it up and heavy in that detail. So taking the radius from up here, and completing that. So it looks like it's probably going down into the next question a little bit, so just for keeping the drawing neat and tidy. Okay, you can see here I just haven't finished it down there, just for keeping the drawing neat and tidy. Okay, also inside in here, this bit in here should actually be hatched, okay, because the sphere is overlapping the cone. And now what I have to do is I have to find that in elevation. So project up my center, and I have the height of it obviously over here found, and the actual position of my center will be right, followed up, followed across, right here, right in there. Okay, same radius, and it's close enough, yeah. There we go. Okay, and once again, as we can see there in this question, it is overlapping the cone quite extensively. Okay, so inside here you'd have hidden detail, hidden detail, hidden detail, and all the way down here as well. The only bit that actually might be heavy is just this bit here. Okay, once again guys, hope you found that question useful, helpful there. Okay, and what we're going to move on to now is question 3 on this page as well. Okay, so I'm going to zoom out to that there now. Right folks, so the next question again is on question 3, and it says, shown are the plan and elevation of a hemisphere. The given point of contact is on the surface of the hemisphere. It annoys me it doesn't say point of contact there. So the given point of contact is on the surface of the hemisphere. We can see it down here in our plan view. and complete the projections of a 50mm high cone which touches the hemisphere at this point and rests on the horizontal plane. So at this time we actually have a cone, okay, and it's touching a hemisphere, okay, so hemisphere, sphere, okay, same principles, alright, and it's 50mm high and it's obviously resting on the ground, it's on the horizontal plane, okay. First of all, we're given the point of contact. What I would always do when we're given kind of the point of contact is I would locate, we have it in plan, but I would locate where it is in elevation, okay. So what we're actually going to do here is we're going to do a horizontal cut. And first of all, to do a horizontal cut, we need to actually do it in our plan first, and that would appear as a circle in our plan, because anytime you cut a sphere, you're going to see another circle, okay. So I'm going to do the horizontal cut there. I'll actually just do it, if you imagine, the whole way around there. You don't have to. The portion that I needed, and you can see I've just left two little gaps there, I only needed technically this portion, because what I want to do is I wanted to bring it around to the axis, okay, where it's basically that line there, okay, that axis line technically is what we see here, okay, of this circumference in our elevation, okay. So what I did is I only wanted to bring it around from here, I wanted it to travel around as far as until it got to there, okay, and at that point then what I would do is I project it up to my elevation. Okay, and it hits right there. Now, the reason I did the cut the whole way around is because technically if I was to cut across it, okay, we would have a horizontal cut going from left to right, like that, okay, and if we were looking down on top of it, okay, looking down on top of it, and that section there was all removed, we'd still see another circle, and that's the circle that we would see in our plan, okay. Now, that horizontal cut gave me a point here on the outside, okay, but what I wanted to do was project that around, or project it across, to locate where that exact point of contact is in my elevation. And I can now bring up the exact point from plan, tell me locate where it is in elevation. I've now found that in elevation, it's right there. Okay, once again, POC, I'm going to write POC down here, alright. Okay, so at this point now, what we actually have to do is we have to kind of use what information it gives us here to basically help us with that. I've technically got the point of contact when it has been rotated around to the extreme curve, okay, it's not really an extreme generator anymore, but it's the extreme curve, okay, of our hemisphere, okay. Technically I suppose you could say it could be a generator if the generator was a semicircular arc and it rotates around, obviously it revolves around. But anyway, all I've done here is the point of contact has transferred over here to this position, which is where we want it at the side of our hemisphere, okay. And we're told that the cone is 50mm high and it touches the hemisphere, and it also is sitting on the horizontal plane. So what I can do there is, it's 50mm height, I'm just going to measure 50mm above my XY line, up to there. I want to do a line across, because that's the height of it, okay. And we know then as well, if a cone was touching, okay, kind of like the last question, okay, when a cone is touching a sphere, or in this case a hemisphere, okay, perpendicular to the extreme generator of the cone through the center of the sphere, okay, so that line there that I've done, that technically there, okay, is a perpendicular line, okay, to the extreme generator of a cone, okay. So now that, and that helps us locate a point of contact. So perpendicular to the extreme generator of the cone, okay. So now that I have that line, all I have to do to find the extreme generator of a cone that I want, okay, is go perpendicular to this line. So literally like that, okay, and that'll help me locate my ghost cone in this case, not a ghost sphere anymore, right? So going perpendicular to that, I am going to set it up, my 45 on it, and as close as I can. I want to get this quite accurate, and literally just slide it across then, okay, and make sure it's going through that point of contact. It's important. And what it's helped me find right up here at the top, okay, is actually the top of a cone that I would need, a ghost cone, okay. I might as well draw in the whole ghost cone as I'm at it. Okay, so what I'll do is I'll project down the center of it, because obviously the center of it will be in that position, and then it will be out here at the side of it, because remember this is at the side of it first, which is where we always need to find it. Okay, but just on that, I'm going to measure that. I'll actually use my compass. You don't have to draw this is not necessary, but it's just for explanation purposes. Measure that distance out the same side. Okay, and that would be my ghost cone, which I'll write in here. Ghost cone. Okay, and obviously as we look down the top of the cone, that's where the center of it will be. Project it down, that's where the center will be when it's at the extreme right of my hemisphere in this case. Okay, so once again, the exact same process. We're going to rotate it around until it's in the position that we want. We know where the point of contact is, and always you join the center of a cone to the center of a sphere to locate the point of contact in plan. We don't have the center of the sphere down here, or the cone in this case, sorry, but we do have the point of contact. So I can connect the center of my hemisphere out through the point of contact, and that will help me locate the center of my cone when it's in the correct position. Okay, I have the radius in my elevation, so I can take that. Just grab that there now, because the radius will be from here to here. I can now draw in that in plan. And slightly gone off below my page at the bottom, outside the border. That's absolutely fine. And what you'll actually notice is I've only done it as far as there, and inside in here is going to be hidden detail, because technically the hemisphere is overlapping the cone. Okay, there's my hidden detail, and now what I want to do is I want to draw that in its correct position in the elevation. Okay, so I'm essentially drawing this exact cone once again, but only in the correct position. So transfer up my center that I found in my plan, which was here, and we know the height of it already, so I went up to there. So now that I have the height of it there, what I could do is I could do a bit of sliding set squares. Okay, just do a bit of sliding set squares, probably the easiest, because this has to be the exact same cone. There we go, and the cone now in this case is in the front of it, so this will be all heavy. Okay, and the exact same here as well. Okay, and there's our cone in the correct position, and obviously inside here technically that should all be hidden detail there and hidden detail there, because the cone is in front of it. Okay, and we've also found the points of contact. Alright, once again, hope you found that helpful, guys. What we're going to move on to now is the last question on this page, question 4. Okay, so I'm going to zoom out to that there now. Right folks, so the last question on this page, it says shown are the plan and elevation of a sphere. So we've obviously got the elevation here, plan down here. The given point of contact is on the surface of the sphere, so you can see it down here in our plan view where they're shown as the point of contact is. Complete the projections of a second sphere, radius 10 millimeters. Okay, so they haven't really told us a radius before. Okay, which touches the given point. Okay. Complete projections of the second sphere, radius 10 millimeters, which touches the given point. Okay. It doesn't tell us that it rests on the horizontal plane either. Okay, interesting. Right. So on this one, what we're going to do first of all is we're just going to build it up. We have the point of contact in plan, so what we're going to have to do first of all is just locate that in our elevation. Okay. When we're getting a point of contact with a sphere, what we're always going to do is the horizontal cuts. Okay. And a horizontal cut in our plan view would appear as a circle. So I'm just going to rotate that around until it's kind of on the axis there. So I've rotated that around in this position here. Okay, and what I want to do is where it hits there, I'm going to project that up to my elevation. And for the sake of this, now they haven't told us it is on the horizontal plane. Okay, they haven't told us that, but so in that case then technically my point of contact could technically be either down here or up here depending on where I took my cut. I'm going to imagine the cut is down here, so I'm going to take it on the lower end. I'm going to imagine the sphere is roughly down here somewhere. Okay, so that cut then would appear as a horizontal cut in my elevation which would run across it. Okay, and yeah, just making sure they haven't said the given point is on the surface here, that they haven't said it's on the top half or anything. No, they haven't. Okay, and find that point of contact in its correct position then. So technically, the correct position of that point of contact in my plan view, in my elevation view, sorry, should be here, POC, and we obviously have in our plan view here, POC as well. Okay, now at this point, what I would like to do is I want to find that sphere, 10mm radius, when it is on the outside of our sphere up here, okay, in our elevation view. Alright, so this one isn't too hard. Two circles touching each other, okay, essentially two balls touching each other, they'll meet at a point of contact on the outside, okay. You'll always be able to see it when you look at them face on, as long as we rotate it around, okay. Obviously the final one we want is in here somewhere, but when it's on the outside, the point of contact will be here or on the outside of the circumference. So we're told the radius, it's 10mm, so very, very easy. I'm going to measure there 10mm out. Okay, and that will give me a sphere. And bear with me now, I'll try and draw it. It's a little bit awkward with this compass here and using a biro with it as the attachment, but I'll try and draw it as best I can. As you can see there, it's a little bit awkward. Okay. Now, what I've actually drawn there is technically the ghost sphere. Ghost sphere, and it has a radius of R10. Okay, ghost sphere, radius 10. Alright, and what I want to do is I want to rotate that until it's in the correct position. Alright, now first of all, that point of contact is here. The real one we want is here. But when that point of contact had rolled around, it was in this position, okay, when it was on the side, alright, on the side of it. So what I'm going to do is, two spheres, when they touch each other, you join the centers, that will give you the point of contact. So what I'm going to do is, I'm going to extend out from the center of the larger sphere through the fake point of contact, okay, and somewhere out along there is going to be my center, okay. Now I'm just after realizing I didn't probably need to do that there, this little bit, but for the sake of it, it'll actually help explain it a little bit. Okay, I could have just measured out from here 10mm. Just realizing that now. So from the center there, could mark out, and you can see it matches up, and that's still going to be 10mm out. Okay, and that's probably where I should have drawn in my ghost sphere. Okay, it's going to be right there. That's where I should have drawn it in. Okay, but you get the idea. That's actually the center of my ghost sphere. So now what we actually have is the height above the XY line of our ghost sphere. Okay, so once again I am actually going to transfer that down to my plan view. Okay, I'm going to transfer this down to my plan view. Okay, and transfer this bit out, and what we have is we have found the center when it is on the extreme right, okay, of our elevation, okay, when it's on the extreme right, and I have found the center in that position there. Okay, just on that, guys, so you don't get confused, make sure it's not this one that you take down, that it's this one. Okay, alright, that's it when it was obviously up along the diameter of the larger sphere. Alright, now what I want to do is I want to rotate that around here until it's in its correct position. So from here to here, I'm going to rotate that around, and we know the points of contact of any spheres, okay, when they're touching, you join the two centers, they'll give you a point of contact. So in this case we have the point of contact on one center connected out through the point of contact, and that will give you where the other center is. So now I've actually found the center of my sphere in plan. Okay, so I'm actually going to draw that in now as best I can once again, so please bear with me. So take the same radius here. Make sure that's the right radius. I'm happy with that. A little bit bigger. There we go. And what I'll actually have is a bit of hidden detail, because as I said, it's on the bottom half, so it's underneath. So inside here, and that's coming out okay actually, because we can see the point of contact is just inside it. Now at this point, what I would like to do is I want to transfer that up to my elevation. I've completed it in plan, and we know the height of that point of the center in our elevation. So once I transfer that up, and I can transfer the center across, I have now found my center in my elevation. And once again, same concept. This time this one will be heavy, because as we know, heavy all the way around, because this is actually at the front, so this will go heavy the whole way around. Hopefully we'll see. I don't know if it touches. Ah yeah, it does actually touch. It doesn't tell us that it touches the horizontal plane, but as it draws on the page, it appears to. Okay, it doesn't tell us that it's resting on the horizontal plane, but as it draws on the page, it appears to. Now inside here, this should be hidden detail. Okay, that should be hidden detail in there, because the smaller sphere is in front of the larger sphere. Okay, once again guys, hope you found that helpful. Purpose of drawing, as I said, disco circle, technically probably should have drawn it in this position, but it's the same thing as it rolls around it, because it just moves around it anyway. Okay, it just helped me find this, but I could have saved myself a step there. When I extended this out through the fake point of contact, I could have just measured from there 10mm to find my fake center, rather than extending out here 10 and then rotating it down. Okay, would have saved me a step, but it's still nothing wrong with it. Okay, once again guys, hope you found that helpful. Try and get those done there for the next lesson guys. That's your work for today. Okay.